ma'am.
Hi. Okay. Good evening, everyone. It's our pleasure to introduce our today's resource person, Mrs. Uma Lakshmi Patne, ma'am. Ma'am is an assistant professor at VPMS BN Bandodkar College of Science, Autonomous, Thane. Her area of expertise include mathematics education and soft set theory. Please join me in extending a warm welcome to Madam. Over to you, ma'am.
Thank you, ma'am.
Welcome.
Hello, everyone. Sincerely thank Winsel College, especially Madhvi ma'am and Tina ma'am for calling me uh, for this particular workshop. So today I am going to take, am I audible properly?
Yes, ma'am.
Okay. So today I will be taking a session on linear algebra. So let me just share my screen. So linear algebra is actually a very, very basic and important course in which students can gain lot of marks, and it is very starts with very, very basic things like matrices, system of linear equations, and further it goes up to vector space. In vector space also you will find problems based on even smallest problems like subspace, dimension. All these problems are there, and linear algebra carries a quite of weightage. If you take any previous year question paper, you will find that there are uh, many problems based on linear algebra. It's a very vast actually concept syllabus, and covering it in 2 hours is not possible. So I will try my best. Okay. So is it visible? My screen is visible to all?
Yes, ma'am.
Okay, thank you. So I would like that the audience, the participants respond to me. Okay, I don't want it a one way. I want it to both ways, two ways. So, so as you can see, my session is on linear algebra. So linear algebra, the first things start is just a minute. Matrices and system of linear equations. So what I will do is I will not just do theory like that. I will just introduce small topics, basic necessary definitions, properties, and directly we will take problems. And for that particular problem, whatever theorem result will be needed, I will discuss that. Okay, so just a second. Not just 1 minute. What? Pen is not giving. Give me few minutes. Okay, I will share again. Okay, I hope it is now visible to all.
Yes, ma'am.
So let us start with the system of linear equations. Uh, so everyone knows that a system of linear equation can be represented by matrix form as Ax equal to B. In that, A is the matrix of coefficient. This is A is the coefficient matrix. Here the coefficients involved are the coefficient in the equations of the system. X is the matrix, column matrix of unknowns, x1, x2 up to xn. And B is also known to us. It is the right hand side vector. So one can denote this as A equal to Aij. Order can be any m cross n. X will be the vector column matrix of the unknowns. Suppose the unknowns are denoted as x1, x2 up to xn. And B will be known to us, right hand side constants. B, it is also a column matrix, B1, B2 up to Bn. So this is how generally a system of linear equations is denoted. Now here, what is m means? This m will represent the number of equations. And n, as you can see, represents the number of unknowns, x1, x2 up to xn. Now in this, if B is equal to 0, 0 matrix, we call the system as homogeneous system of linear equations. Yes. And if B is not equal to 0, we call it as non-homogeneous. And then the main thing involved in a system of linear equation is finding the solution. Okay, solution means what? Finding the value of the unknowns. That is this x. So x here, whatever x we find will be called a solution. Okay, A is known to us, B is known to us, x is the unknown. So x is the solution of the system. And for homogeneous and non-homogeneous, there are different conditions for the existence of the system. So let me just discuss quickly. For homogeneous, homogeneous system, there are only two possibilities. First is, so you can observe that zero solution always exists for a homogeneous. Zero means it is also called as trivial solution. If B is 0, I can take all my x1, x2, xn 0, I will get Ax equal to 0. So it is going to satisfy always. Okay. And sometimes there is only zero solution. Means zero solution itself is the unique solution. That happens if determinant of A is not equal to 0. Okay. That is, the system is, the matrix A is invertible. And then there is second option, second possibility, that is a non-trivial or non-zero solution exists. Non-zero solution exists means there are infinitely many solutions. This is the case. Even if you get one non-zero solution, any alpha times that is also going to be a non-zero solution. Infinitely many solutions. So this happens if determinant A is equal to 0. That is, matrix A is singular. Okay. Or you must have done the theorem in your very first semester. If m is less than equal to n. What is m? M is the number of equations and n is the number of unknowns. So a homogeneous system will always have a non-zero solution if m is less than equal to n. So this theorem is used many times. So all the solution, in case 2, if I take all the solution, it forms a solution space of the homogeneous system. So what is the dimension of such solution space? So dimension of solution space of a homogeneous system Ax equal to 0 is given by, the theorem is, says n minus r. Okay, what is n? We already know n is the number of unknowns. Okay, number of unknowns, or we can also say the columns of matrix A. And r is actually rank of A.
मैम
Yes.
बट जो ऊपर अभी आपने बताया ना होमोजेनियस सॉल्यूशन के दो पार्ट पर डिटर्मिनेंट डिटर्मिनेंट की बात हम तभी कर सकते हैं ना जब मैट्रिक्स अपनी स्क्वायर मैट्रिक्स हो जब
Yes,
तो
correct.
व्हाट हैपन व्हेन मैट्रिक्स इज नॉट
Not a square. That means either the case is m is less than n or m is
ग्रेटर
strictly
देन
greater than n. Okay. So if m is strictly greater than n, then only one possibility, that zero solution. Because the number of equations are less and the unknowns are more. And if m is less than n, in that case, we will get a non-zero, non-trivial solution always. Okay.
ओके मैम
So let me write here slash. Thank you for suggesting this. M greater than n, and in some cases or m equal to n also. Okay, because if sometimes if m is equal to n, that means the matrix is invertible. In that case, we may get the unique solution, that is zero solution. We have to check the determinant in that case. Is this clear?
Yes.
Okay. So this result is also used many times. The problems are based on this result. Proof is covered, I think, in second year when we study rank nullity theorem in linear transformation. We prove this result. Dimension of solution space of the system is given by n minus r. So what is r? R is rank of A. And I will come to this part later, how to find rank of a matrix A. Now let us come to the non-homogeneous system. Now in non-homogeneous system, there are three possibilities. Okay. The first possibility is no solution. no solution at all. In that case, we call the system as inconsistent. We say the system is inconsistent. Second, unique solution. Again, unique solution exists if determinant of A is not equal to 0. You have already studied the Kramer's rule in your school or junior college also, or may have revised again in your BSc courses. In this case, we can use the Kramer's rule. Okay. And the third possibility is infinitely many solutions. Infinitely many solutions exist. In that case, determinant is 0. Okay, so this no solution case doesn't exist in homogeneous. Homogeneous में क्या होता है? Zero solution हमेशा है, always. Whatever may be the system, Mn कितना भी हो, zero solution is always there. So the inconsistent part is never coming in homogeneous. In non-homogeneous, we may have inconsistent system. Okay. Now, how to solve the systems? So for that, we have Gaussian elimination method. So what is Gaussian elimination method? Does everyone know this method? Or should I discuss it in detail? किसी ने सुना ये मेथड का नाम?
Yes.
Yes, Ax equal to B is the system. We consider the augmented matrix.
A, B.
Augmented matrix is, yes, AB. That is in the matrix A itself, the last column we add as B, then that is called as the augmented matrix. So the aim of this method is to convert this augmented matrix into row echelon form. Not I. I is for finding inverse of a matrix.
Yeah.
Okay, so you just have to convert in row reduced or row echelon form is also enough. So how to convert a matrix into row echelon form? Anyone? How
By
to convert?
applying row operation.
Yes. So using elementary row operations. So elementary row operations, how many types are there?
3.
3 types. Yes, very good. So in that, first one is interchanging two rows, Ri, interchange with Rj. Second is multiplying by a non-zero scalar, Ri, ith column, ith row is multiplied by alpha. Alpha is not equal to 0. And the third one is adding a scalar multiple of the other row, Ri plus alpha Rg. The same operations are valid for column.
I not equal to J.
Yes, yes. Okay. Now the same operations are valid for columns also. You can have Ci interchange with Cj, Ci change to alpha times Ci, Ci change to Ci plus alpha times Cj. Okay. So mostly row operations ज़्यादा use होते हैं, थोड़ा visualization में easy पड़ता है, that's why. Now what is row echelon form or row? There are two, row reduced echelon form or row echelon form. So row reduced echelon form, in that the first condition is 0 rows if any should be last. 0 rows if any should be last. मतलब last में है. Then first non-zero element जिसको बोलते हैं pivot element, मैं short में लिख रही हूँ, should be 1. Okay. And then third condition. So in each row we have the first non-zero element as called as pivot element, and it should be 1. And pivot element of any row, of any kth row. This is important. Pivot element of kth row should be on right side of all the previous pivot elements, all the pivot elements of the above rows. Okay, that's why it gives us a like an upper triangle, not exactly upper triangular, but sort of upper triangular form because of this, that the pivot element of kth row is on the right row. Now, if we just, instead of 1, we can have just non-zero. That case, we call it as row echelon form. If the first element, non-zero element, is converted to 1, then we call it as row reduced echelon form. So using this, we can convert the augmented matrix, okay, into a row echelon form. Now, when we convert this for a 3x3 matrix, suppose 3x3 system, we may have 3 possibilities. First possibility is like this. Star means some non-zero. These 3 are 0 and this is a non-zero element. This means which case? Can anyone tell?
No solution.
No
Yes,
solution.
no solution. Correct. Because what we will get after simplifying, after multiplying, we will get 0 equal to star, where star is a sorry, non-zero solution. So this gives us inconsistent case 1. Then we may have, I'm just talking about 3x3 system. Okay. Similarly, you can have other order also. If this is the case, what do you think?
Infinite solution.
Finite.
Yes, very good. Infinitely many solutions. And then the third one will be, you will have a proper
Unique.
upper triangular, yes. The row echelon form after reducing it into row echelon form, like this. So in this case, we have unique solution. Okay. Now, using this row echelon form, we can also find rank of any matrix. I will not go in the definition of the rank. It will take a lot of time. I will just tell you how to calculate the rank in the problems is convert it into row echelon form, calculate the number of non-zero rows or the number of pivot elements. Okay, number of pivot elements is same as number of non-zero rows which we get in the row echelon form, row reduced echelon form. That will give us the rank of the matrix. I hope the definition is clear. Let us go to the problems itself. Okay, matrices के बारे में मैंने ज़्यादा नहीं discuss किया, but this is the very basic thing in this problem. Is it visible? I hope the font is okay. You can read it. Yes, can anyone?
Yes, ma'am.
So here what is given? Matrix is given. Aij denotes the entry of M inverse and A41 is asked. Now this is very basic problem actually. What formula we use? A inverse is adjoint of A upon, everyone knows this, determinant of A. And what is adjoint of A? Transpose of the,
Cofactor matrix.
yes, or minus or matrix of cofactors. So Mij. So Mij is, sorry, here we also have minus 1 raised to, let me write Cij cofactors. So where Cij equal to minus 1 raised to I plus j Mji. Right? So here they are asking you A41. So let's just quickly calculate karo. Kya aega? I have given the formula. So A41 will be minus 1 raised to 1 plus 4, that is 5. M41. Sorry, M14. So M14 here, A14 is this. You have to delete this row and column. And whatever the remaining matrix is, find the determinant of that. 1, 0, 1, 2, 1, 0, 3, 2, 1. Now, one more thing I wanted to discuss is finding determinants. That is also used a lot. तो determinants find करने के लिए एक तो हमें definition पता है, Laplace expansion, everyone knows. Okay, in that also we can Laplace expansion, we can use any row and any column, right? Using ith row or ith column. So one can use it. So one can use the particular row or column which contains maximum number of zeros. It will save our time. Or you can use the properties of determinants to calculate the determinants fast. In that, for this we must know, see, these are the 3 row operations. So we must know what is the effect of this 3 row operation on the determinant. So I will just tell you orally, if this row operation is performed, what will be the effect on the determinant? Can anyone tell me? If we interchange 2 rows or interchange 2 columns, what will happen in the determinant?
Nothing.
Minus of the
Yes, the
previous
sign will change,
change.
correct?
Hmm.
Yes. And when you are multiplying a row by alpha,
Then multiplied by alpha.
1 by alpha. Okay. So you are taking alpha common outside. So you can, that means what? We can take any alpha common from a row or from a column outside the determinant. And in the third, there is no change. This is very important. This row operation will have no change in the determinant. So we can use it as many times to simplify our matrix, obtain as many as zeros possible, and use Laplace equation in that particular row or column which has maximum zeros and quickly find the determinants. Okay. For example, in this case, so here already we have 0 in the second row. So what I can do is I can perform quickly R3 minus R1. And what will happen? I will have 1, 0, 1, 2, 1, 0. This will have become 3 minus 1, 2, 2, 0. So third column. So this is the third column we can use in Laplace expansion to find the determinant. Third column. So what you have to do is take the sign as plus, minus, plus. This is how we take the signs for the columns, for the elements. So 1 इस position में है, उसका sign क्या है? Plus है. So when I expand this using third column, these two are already 0. तो हमें सिर्फ एक ही term मिलेगा 1 into that particular row and column. You have to delete. So this row and this column I have to delete. What is left? 2, 1, 2, 2. उसका डिटर्मिनेंट. और बचे हुए 2 टर्म 0 है, इसलिए एक्सपांशन में वो 0 हो जाएंगे. अभी मैं यहाँ पे सब पूरा लिख रही हूँ. But in, of course, in exam, you will do all this thing orally. We will quickly get the answer as 4 minus 2 equal to 2. And already we have minus sign outside here. So what is the answer here? Minus 2. Now see, you want to find determinant of A. In this case, M. Determinant of M find करना है. 4 cross 4 matrix का पूरा आप expansion करोगे using first row. So it will be very time consuming. So what is the best way? As I told you, use the elementary row operation, simplify and try to get as many zeros as possible. So in this problem, and now if you see, so here already 1 is there. We'll keep it as it is. This 2 and 3 I can make 0 using this second row R2, right? So what row operations we have to perform? R3 minus 2 times R2 and R4 minus 2 times R2. So these two elements will become 0. This is already 0. So I can use the first column and expand it. And in that only one term we will get. So it will be very, very time saving. Okay, so quickly do these operations and tell me what is the determinant of matrix M. सबको समझा मैंने क्या बोला, क्या करना है? 0 1 2 3. Second row is 1 0 1 2. So here I will perform R3 minus 2R2. This will not have any effect, any change in the determinant. So directly use कर सकते. This will become 0. This will become 1. This will become minus 2. And this becomes minus 3. Right? Again, this will become 0. This becomes 2. 1 minus 3 minus 2. This becomes minus 6. So now which term we are going to expand using first column? So this is plus. This will have minus sign. So when you expand it, you will have minus 1 into the determinant of the remaining 3 cross 3 matrix, which is obtained by deleting that particular row and column containing 1. So they have to delete this. So what is left? 1 2 3 1 minus 2 minus 3 2 minus 2 minus 6. Now you can see immediately, you can see this 2 will become 0. Even this will become this 2 will become 0, and many 0 terms we will get. So I can make this to 0 instead of expanding the whole thing. Again perform R2 plus R1 and R3 plus R1. So this is minus determinant of 1 2 3. R2 plus R1 will give 2 0 0. तो ये R3 plus R1 नहीं किया तो भी चलेगा, but let us do it. We get 0 ना, जितना 0 मिलता है उतना अच्छा है. So what I've done here, performed R2 plus R1 and R3 plus R1. So now see, second column use कर सकते हैं या second row भी use कर सकते हैं. तो second column use करना है, so this is plus sign, this is minus. So 2 के लिए term आएगा minus sign, and delete this column and row. So 1 minus is already there, minus into minus will become plus 2. Then you have minus 6 minus 0. So your answer is minus 12. So determinant of M is 12. So A41 will be equal to minus 2 upon minus 12, 1 by 6. They are asking us to round off up to 2 digits. So I get 0.17. And the range in the answer key is given as 0.15 to 0.18. तो उसमें हमारा आ रहा है. So this is the correct answer. So what you have learned in this problem is determinant को पूरा एक direct without thinking just expand करते रहोगे first row से. So it will become half an hour you will do this problem only. So what you have to do is use these properties, use the row operations, simplify and find the determinant value. Always, not only in this problem, जब भी determinant का आएगा इसे row operations करके maximum zeros लाना है. So that will save our time in calculating the determinant.
Okay,
So,
ma'am.
any doubt in this particular problem?
No, ma'am.
Okay. Now see this question. 2 cross 2 matrix 1 1 1 0 and the 8th power of M. They are asking 1 0 xy. I think this is quite simple. ये कर लेंगे सब लोग?
Yes, ma'am.
Yes. Okay. Now see rank is asked. So again, as I told you, rank के लिए क्या करना है? Convert the matrix into row echelon form. So we have इसका maximum rank आ सकता है 4 because we have only 4 rows here. So what you have to do, convert it into row echelon form. So what operations you have to perform in the first row? You have to perform R2 is changed to R2 minus R1. So that will give
And
you
the question is not visible. Can you zoom that?
okay. So I will write the matrix. They are asking us what is the rank. Just very straightforward question. जो पार्ट ए में आते हैं इस टाइप के क्वेश्चंस बिगनिंग में जिसमें नेगेटिव मार्किंग्स है. सो इसमें एक साफ प्रॉब्लम्स बहुत इजी होते हैं. कैलकुलेशन करेक्टली करना पड़ता है हमें. सो दिस इज द मैट्रिक्स. लेट मी रीराइट इट अगेन without this operation. 1 1 1 0 0 0 1 0 0 1 1 0 0 1 0 1 0 1 0 0 1 0 1 1. इसका रैंक पूछा है. So you have to convert this matrix into row echelon form. So for that, what we have to do? This particular number 1, we have to convert it into 0 because we want the pivot element of this row on the right side of the previous. So यहाँ से non-zero element start होना चाहिए. तो ये compulsory 0. This is the pivot element of the first row. तो उसके नीचे सब 0 ही होना चाहिए. So for that, we have to perform R2 minus R1. So when you do R2 minus R1, what you will get? 1 1 1 0 0 0 0 minus 1 minus 1 1 1 0. Okay. The remaining two rows will remain as it is. Okay. Now see. So ये हो गया. Let me do it in green. This is the pivot element of the first row. उसके नीचे सब 0 होना चाहिए क्योंकि सेकेंड रो का pivot element उसके right में होगा. So this will be the pivot element if you convert it into 1. 1 को convert करने के लिए क्या करना पड़ता है? Multiply throughout by -1. But in problem, in exam we don't have to do that. Reduced में नहीं किया तो भी चलेगा. Row echelon form is enough. So this is the non-zero rows find करना है हमें. ये हो गया non-zero. अभी इसके नीचे दोनों 0 होने चाहिए. This one is already 0. So to convert this into 0, we have to perform. Yes, what will be the row operation?
R3 plus R2.
R3 plus R2.
Correct. R3 plus R2. So 1 1 1 0 0 0 0 minus 1 minus 1 1 1 0. So R3 plus R2 will give this 0 minus 1. Sorry, 2 1 1 and the last row. Okay. So 3 pivot elements we have got. That means 3 non-zero rows. थर्ड रो का ये हो गया नॉन जीरो. फर्स्ट नॉन जीरो एलिमेंट. इसके नीचे भी 0 होना चाहिए. So you have to perform. Next row operation will be R4 plus R3. Okay. So that will give us, let me just write the last row. 0 0 0 2 2 2. So ये पाइवट एलिमेंट हो गया. सेकेंड रो का ये पाइवट एलिमेंट है. थर्ड रो का ये है. सो फोर्थ रो का पाइवट एलिमेंट 2 है. So this how many pivot elements? That is non-zero leading elements are 4. That is 4
Yeah.
non-zero rows. That means rank is 4. D option. Okay.
Yes, ma'am.
Okay. So I hope this one is readable, the question.
Yes.
Okay. So what is given? Let A be a 6 cross 5 matrix with entries in R and B is a 5 cross 4 matrix with entries in R. So P is what? For all such non-zero matrices A and B, there is a non-zero matrix Z such that AZB is the 6 cross 4 zero matrix. Now what they have given is A multiplied by Z multiplied by B equal to 0 matrix of what order? 6 cross 4. A का ऑर्डर दिया है 6 cross 5. B का ऑर्डर दिया है 5 cross 4. That means what should be the order of Z?
5 cross 5.
Correct, Sunil. 5 cross 5. And what is unknown here? Z matrix is the unknown, right? A is given, B is given, 0 matrix is known. So Z is unknown और Z का order 5 cross 5 है. Means how many unknowns are there? M equal to 25, right? There will be total 25 elements in the matrix Z. The matrix Z is unknown, means the number of unknowns here is 25. And how many equations will be there in this system? Can anyone tell?
6.
6
6, yes.
equations.
4.
The number of rows will be 6. I agree. I am asking you if I solve the system. अगर ये मैं पूरा system लिखूंगी
4.
कितने equations आएंगे? No, think about it. You can think for 2 cross 2 matrix if you want. 2 cross 3. See, unknowns कितने हैं Z में? 25 unknowns है, correct?
Yes, ma'am.
Yes. So when you solve it, yes, actually, I can take, yes, I think I can take N as 6, right?
Yes,
The
ma'am.
number, yes, I'm
Yes,
sorry.
ma'am.
N will be 6 because when we solve it, we'll get the equations will be 6 because the right hand side they are giving as 6 cross 4. That means the number of equations are 6 and the columns are 4. So when you see here, M is greater than N. Just a second. Let me just revise this part. How many equations will be there? So if I have I can say total number of unknowns are 25, number of equations I think actually there will be 24. See, because this is not a column. जब हमारा column रहता है सिर्फ B1, B2, Bn, so there are Bm. So there are just m equations. But what we have here is what? A matrix है पूरा का पूरा. 6 cross 4 matrix है. So that's why how many equations will be there? There will be 24 equations. कि यहाँ का first entry is an equation equal to the first entry here which is 0. So ये पूरा matrix जब हम calculate करेंगे 5 cross 5. This 5 cross 5 matrix, suppose I write A11, A12, right? A13, A14, A15 equal to right side में सॉरी 4 ही कॉलम्स है तो A14 6 cross 4. Now what will be A11? See, A11 itself will be an equation. Do you agree? A into Z into B जब करोगे,
Yes, ma'am.
it will be an equation containing the unknowns of the first column of matrix, first column and first row of the matrix Z. तो ये पूरा का पूरा एक equation मिलेगा. A11 equal to 0 will be the first equation in the system. A12 equal to 0 will be the second equation of the system. So like this total, how many equations will be there? 6 into 4, 24 equations will be there. And we have, मैंने उल्टा लिखा, sorry, equations. M is the equations which is 24 and unknowns 25, n equal to 25. So equations are 6 into 4, 24, represented by m. Number of unknowns, that is variables of z, 5 into 5, 24 is n. So here we are getting what case? M less than n, and it's a homogeneous system. So as we have discussed, this results in what? Non-trivial solution. This gives us a non-trivial solution. Means what? In this case, non-zero solution is nothing but Z, so non-zero matrix, and hence non-zero matrix exists. So option P is true. That is what we come to the conclusion. P is true. Yes, there will exist such a non-zero matrix. Now in the second part Q, let us see what they are giving. Q में उन्होंने दिया है B into Y into A is zero matrix of order 5 cross 5. So B का ऑर्डर है 5 क्रॉस 4, ए का ऑर्डर है 6 क्रॉस 5, तो y का ऑर्डर क्या आएगा 4 क्रॉस 6.
Cross 6.
Now y is unknown here, so how many unknowns are there? n 6 into 4 24 unknowns, and right side में जीरो मैट्रिक्स है 5 क्रॉस 5, तो इक्वेशंस कितने आएंगे 25.
25.
So in this case m is greater than n, so this means what? If m is greater than n, that means the solution will be trivial solution. Correct? Is this clear to all? So that means what? Trivial solution matlab zero matrix. So the Q is statement is false. So we come to the conclusion then P is true, but Q is false. Okay, any doubt in this? Okay, let's move to the next question. Now it is again a very straightforward question. A system is given. So if you write the augmented matrix of this system, what we will have? There are, if you see, there are how many variables? X, Y, Z, T. 4 unknowns are there. Whereas lambda is a constant. Okay, so lambda is not an unknown. Although it's a not known, but it's not a variable, it's a constant. So augmented matrix, if you write x का coefficient है 1 by 1, z नहीं है first equation में, मतलब z का coefficient 0, t का coefficient 1. Second equation में x coefficient is 2, y and z are not there, मतलब 0 0 minus 4. Third equation 1 1 1 0. Last equation 1 minus 3 minus 1 minus 10. And the right hand side constant 4 7 5 lambda. If we read the question, what they are asking, the possibilities of unique solution or infinitely many solutions. So उसके लिए हमें क्या करना पड़ेगा? Gaussian elimination method use करके convert this matrix into row echelon form. So again, the pivot element 1 is present. उसके नीचे ये तीनों भी हमें क्या करना है? 0 में convert करना है. So for that, what are the row operations we have to use? R2 minus 2R1, R3 minus R1, R4 minus R1. Correct? So when you do that, क्या मिलेगा?
मैम
So we, हाँ,
प्रीवियस क्वेश्चन पे जाना एक बार.
yes.
मैम इसमें क्यों ट्रू क्यों नहीं हो सकता?
Because we have m greater than n here.
But what
Hmm.
happen when we take y as an nilpotent matrix?
Y as a,
Y is nilpotent matrix and A
okay.
also a nilpotent matrix means y और A दोनों equal हो, ठीक है, दोनों 2 2 इंडेक्स की हो, देन y A मल्टीप्लाई होके टुगेदर में जीरो मैट्रिक्स फॉर्म कर देगी.
Y equal to 0 matrix you are saying? No.
नो y इक्वल टू 0 नहीं, y
Hmm.
एक nilpotent मैट्रिक्स ले हम, अगर n
Hmm.
लेट्स से 2 इंडेक्स की,
Okay.
ठीक है, एंड ऐसे ही a मैट्रिक्स भी अगर हम 2 इंडेक्स की एक nilpotent मैट्रिक्स ले,
Okay.
तो व्हेन वी मल्टीप्लाई बोथ देन प्रोडक्ट विल बी 0। मतलब हम इस वे में ले y और a को
नहीं
ऐसे
नहीं,
चूज करें,
बिकॉज
क्योंकि यहाँ
सी
क्योंकि
नीलपोटेंट का डेफिनेशन क्या है वो बताओ पहले. व्हाट इज अ नीलपोटेंट मैट्रिक्स? कैन यू टेल मी?
मतलब हम ऐसी मैट्रिक्स जिसकी मतलब kth पावर करने पे 0 आई और k लीस्ट पॉजिटिव इंटीजर हो।
Yes, but nilpotent has to be a square matrix, right? Then only you can find the kth power. Y square is not defined here. A square is not defined here. Correct? What is the order of Y? 4 cross 6. Order of A is 6 cross 5.
यस
Right?
मैम, यस यस यस।
हाँ. So nilpotent तो इस केस में नहीं आएगा. Can you give any other example? See, homogeneous का ये है, यही result है actually. So if m is less than equal to 1, then you will always have a non-trivial solution. And if that means if m is not less than 1, less than n. So in the other case is only what? Trivial solution वाला. Inconsistent तो नहीं आता इसमें case. So if you have m greater than n, that means the solution is always going to be a trivial solution. Okay. You can try to find an example for this.
ओके
Take your
मैम,
time after the lecture.
ओके ओके।
I will give my number later. So I will check your example. Okay.
ठीक है मैम।
चले. So coming back to this problem. So I hope others have solved this. What you get here? 1 0 0 0 1 1 0 minus 4. If there are some mistakes in my calculation, please let me know. 0 0 1 minus 1. If your answer and my answer is not matching, we can find out किसका mistake है. 4 half. Sorry. I combined 2. इसी में मैंने एक और भी ऑपरेशन करके उसको लिख दिया है. You must have got here -2 -2 -6. Correct? I think this is -1
Yes.
Yes, ma'am.
1 lambda -4. कि उसके बाद मैंने किया था इसको सेकेंड रो we can divide by -2, or without that also directly what we can do is perform this. This is the leading non-zero entry. उसके नीचे दोनों 0 चाहिए, तो -4 को डायरेक्ट भी 0 कर सकते हैं without converting -2 to 1 also. That is by R4 -2 times R2. Correct? R4 converted to R4 -2 times R2 will give what? 1 1 0 1 4 0 -2 0 -6 -1 0 0 1 -1 1 0. ये हो जाएगा 0. This will remain -1. -11 plus 12 will give us 1. And this will be lambda -4 plus 2. Okay. That means lambda -2. Now still this is not in row echelon form. Right? Everyone agrees? This is the leading non-zero pivot element of first row, second row, third row का pivot element है. इसके नीचे ये element को भी हमें अभी 0 में convert करना है. So for that we have to perform R4 converted to R4 plus R3. We do this. I will just write the last row now. This will become 0 0 0 0. और यहाँ पे हो जाएगा lambda -2 plus 1, lambda minus 1. Correct? So what is our conclusion now? I've told you the cases. If this is 0, means if lambda is equal to 1, this will be 0. In that case, what we will have? Infinitely many solutions. Lambda equal to 1, मतलब नीचे का पूरा row 0 है. That will give us, and since it's a 4 cross 4, this means it will be a infinitely many solution. And if lambda is not equal to 1, in that case, that means no solution, inconsistent. Unique solution का possibility तो है ही नहीं. So when you see the options, we get C as the answer. Lambda equal to 1, then the system has infinitely many solutions. Okay, any doubt in this?
No, ma'am.
Okay.
No, ma'am.
Similarly, you can try this also. Now, I will not do this problem. I will leave it to you. A system is given. यहाँ पे दो constants involved है, alpha and beta. Same way you have to do, take the augmented matrix, convert it into row echelon form and just check the last row. सिर्फ last row देखना होता है, जैसे हमने यहाँ पे देखा है. After converting into row echelon form, see the last row. What is the possibilities? As we have already discussed the 3 cases for non-homogeneous, you have to see what are the 3 cases in this and find the solution. Let's move to the next question. Now see, a very straightforward question, but यहाँ पे numbers बड़े बड़े हैं, numbers में कुछ patterns है. Okay. Sometimes this is actually a very repetitive question. इसमें क्या होता है, कभी कभी ईयर भी डालते हैं वो लोग, 2024, 2025 instead of 11 and 10 they will replace it by 2024 and 2025. So यहाँ पे actual direct matrix determinant नहीं calculate करना है, कभी आएगा भी नहीं, it will be very time consuming. What you have to do is perform the elementary row operations, simplify, try to get as many possible, जितना भी zeros आ सकते हैं करना है, and then that will give us the answer fastly. So what we can do is here, can anyone suggest how to simplify and find the determinant here? Any suggestions? What properties we can use or what row operations we can use here?
Row 3 minus row 2, row 4 minus row 2.
Yes, correct. Even I can do R2 minus R1 also, no? That will simplify. बाकी के यहाँ पे 0 मिलेंगे, right? Remaining elements.
Yes, ma'am.
R2 minus R1, R3 minus, I have to do it. इसको बाद में करते हैं. R2 minus R1 लास्ट में करेंगे. We'll start with below. R4 minus R3. उसके बाद या फिर R4 minus R3 भी कर सकते हैं, R4 minus R2 भी कर सकते हैं, R3 minus R2, and then we will do R2 minus R1. Okay, in this order. These 3 operations will not change the determinant. So determinant of M will be 11, 10, 10, 10. So this is 0, minus 1, 0, 1. Correct? Then R3 minus R2 will give 0. Again minus 1, 1, 0. Then R2 minus R1 will give minus 1, 1, 0, 0. So see, so many zeros and 1. It will simplify our work. What else you can do? और इसको सिंप्लीफाई कर सकते हैं. अभी किसी भी यहाँ पे मैक्सिमम क्या हो रहा है, इस रो में 2 zeros है कि मैक्सिमम 2 zeros है. कैन यू मेक 3 zeros in any row or any column?
And we can further apply a row operation to R1 using R2. It can be also
Interchanging?
no, ma'am. Yeah, R1 changes to 11 R2.
Yes, correct. R1 plus 11
Il-
times R2,
R2.
correct?
Yes, ma'am.
So what we will get the answer then? Determinant of M. This will become 0. This will become 21, correct? This
Yes,
will be
ma'am.
10 and 10. Correct? Everyone? So first row has maximum zeros now. So we will expand the determinant using first row. साइन देखना पड़ेगा, एक्सपांड करते वक्त हमेशा साइन देखना है, प्लस से स्टार्ट होता है, दिस प्लस, दिस हैज माइनस साइन, so that why, and already -1 is there, and you have to delete that particular column and row. That is first row and second column will be deleted. So minus of -1 into what will be left is 21, 10, 10, -1, 1, 0, -1, 0, 1. Again, instead of expanding, again you can simplify, make zeros. This 10 can be made 0, right? Using this particular 1. Correct? What will be the row operation?
Yes.
R1 minus
R1
10
changes
times
R2.
R2. So ये हो गया determine. अब ये minus minus cancel हो जाएगा. So this becomes, tell me, 31.
31.
Correct?
Yes,
0,
ma'am.
10. Am I
Yeah.
correct?
Yes.
Yes. Now see, second row you can use in the using expand the determinant using second row, plus minus. This particular has middle term has plus sign while expanding, and 1 is there, and you have to delete that particular row and column. So what will be the answer? Remaining is 31, 10, minus 1, 1. So that is 31 minus of minus 10 plus. So your answer is 41. That is your final answer. So this is how you're supposed to do. Okay, ईयर बहुत कॉमन है कि ईयर आता है, अभी 2025 तो 2025 2026 आ सकता है, या कोई भी रैंडम दो बड़े डिजिट्स आएंगे, तो उसको ऐसे ही करना है. यू हैव टू perform the row operations, or even column operations are also allowed, and simplify your work, obtain maximum zeros in a row or in a column, and use that particular row and column to expand and find the determinant. Okay, let's move to the next question. So I will move to the yes.
In the previous question, you used plus one. Why you use plus one?
Which previous question you're talking about? This one?
यही question.
हाँ, इसमें क्या हो गया?
No मैम
ये प्लस बोल
ये
रहे हो
वाला
आप? ये ना?
आपने one. Yes मैम.
You're not audible. Please repeat the question.
मैम मैं पूछ रही थी कि आपने जो प्लस साइन यूज किए हैं क्यों यूज किए हैं, मतलब नेगेटिव पॉजिटिव नेगेटिव या किसके लिए, ये पूछ रही थी.
हाँ, वो टर्म आता है ना -1/i+j, जो लैप्लास एक्सपांशन हम करते हैं कोई भी रो या कॉलम पे, तो फॉर्मूला में क्या होता है? -1/, so if you
Yes
are
मैम.
expanding, हाँ, so suppose you are using here, अभी ये टर्म यूज कर रहे हैं, ये वाला, राइट? ये यूज किया हमने. This represents
Yes मैम
what?
got it. Yes मैम.
Okay.
Yes मैम. Yes मैम. Yes मैम.
ठीक है.
A2.
You can just remember, no, I draw, पहले भी मैंने ड्रॉ किया था, प्लस माइनस प्लस, ये ऑल्टरनेट होते जाते हैं, राइट? दिस इज फॉर 3x3. ज्यादा ऑल्टरनेट साइंस, इवन ऑड. ठीक है. Let's move to the next topic, that is vector spaces. Now in vector spaces, what are the different things that can come in the exam? So definition of vector space का ज़्यादा यूज नहीं होता एग्जाम में, so I will just not go in this. We know all the 8 properties which are required for a vector space. उसके बाद आता है सबस्पेस. इसमें काफी प्रॉब्लम्स आ सकते हैं. सो सबस्पेस का डेफिनेशन है. सो लेट V be a vector space, V plus dot be a vector space, and W is any subset non-empty subset of V. So then W is a subspace of B is called a subspace of V if it itself is a vector space under the same operations. Okay. Now let me write the actual properties. एक result होता है कि उसमें सिर्फ 2 ही चीज देखना पड़ता है subspace के लिए. This is a standard theorem. The first thing is that the zero vector in the vector space V should belong to W, and the second property is alpha V1 plus beta V2 should belong to W for any alpha beta scalar, and V1 V2 belong to W. इतना काफी है. सारे के सारे 8 प्रॉपर्टीज. रिमेनिंग प्रॉपर्टीज है कम्यूटेटिव, एसोसिएटिव, वो तो होगा ही satisfy. If it is satisfied for V, it is going to satisfy W. So main thing is we have to check these 2 things for the subspace. First is zero vector should belong to W, and alpha V1 plus beta V2 should belong to W, where V1 V2 belong to W and alpha beta are real numbers. Okay. Then what are the next thing which we study is linear combination of vectors. I will write everything in very short because time is less. So if we have V1, V2 up to Vn vectors, then any combination of this type A1, V1 plus A2, V2 up to An, Vn, where all these A1, A2 up to An are scalars and V1, V2 up to Vn are vectors is called a linear combination. Then comes the definition of linear independent vectors. Linearly independent vectors. So in a vector space V, vectors V1, V2 up to Vn, non-zero vectors, are called linearly independent vectors if we have, say, A1, V1 plus A2, V2 up to An, Vn. This linear combination is 0. If it is 0, it implies that all the coefficient must be equal to 0. That is, if only combination possible is 0 V1 plus 0 V2 up to 0 Vn equal to 0. In that case, we call the vectors are linearly independent. So if even one of this coefficient is non-zero and the linear combination is coming to equal to 0, in that case, we say that the vectors are linearly dependent vectors. And then after this, we study linear span. Linear span of a set S containing some n vectors V1, V2, Vn is nothing but what? Is the set of the combination of all the linear combinations of these vectors. All set of all linear combinations of the vectors v1, v2, vn. And we denote it as L of S. Okay, linear span of the set S. Then what we have next is, इसके बाद हमने पढ़ा है basis. So if there is a set of non-zero vectors, suppose v1, v2 up to vn, it is subset of our vector space V and all the vectors are non-zero here. So B is called a basis of V. There are two conditions. If the first condition is the B set should be linearly independent, is a linearly independent set. And the second is when we take the linear span of this, it should be whole of V. We also call that B is a generating set of V. So if these two conditions are satisfied, we say that B is a basis of the vector space V. And from this, we can say the definition of dimension of V is nothing but number of elements in any basis. Okay, there is a result, in fact, if V is a vector space, first thing is it can have more than one basis. Okay, basis कभी भी unique नहीं होता. कोई भी vector space can have more than one basis, but the number of elements in each basis will be same. Okay, and hence since the number is same in any basis, we can define it as the dimension of V. The dimension of V is the number of elements in any basis of that particular vector space. Now if W is a subspace of a vector space V, then there are some properties you must know. First thing is dimension of W will be always positive. Any vector space dimension will be positive. Second, dimension of W will be less than equal to dimension of V. And third, dimension of W will be equal to dimension of V if and only if W equal to V. Okay, these are the results which you should know depending on the problems. Let us move to questions directly now. So read the question here. Which of the following is a subspace of the real vector space R3? So as we have discussed, subspace के लिए सबसे first thing is zero vector should be there. तो पहले चारों को देख लेते हैं. इसमें zero vector आएगा. First इसमें if I 0, 0, 0 is the vector. What is the zero vector here? In R3, 0, 0, 0. So zero vector belong करेगा A में? Yes.
Yes, ma'am.
0 belong करेगा. 0 is a rational number, so यहाँ पे भी belong करेगा. Y into Z 0 है तो यहाँ पे भी belong करेगा. But here, zero vector does not belong. Correct?
Yes, ma'am.
Yes, ma'am.
So ये चला गया अपना. Now remaining 3 में से देखना है. Second property. What does the second condition is there for subspace? Alpha V1
Alpha V1
plus beta
V2.
V2 should belong to W whenever V1, V2 is belonging to W. Okay.
Yes, ma'am.
So in that, now clearly B option में, see alpha and beta can be any real number. Although addition of two rationals is rational, but when I multiply by a scalar, if the scalar is irrational, the answer will be an irrational. So in B option is not a subspace. Okay. What I can take is I can take alpha as any irrational. That will give what? Alpha into y is also irrational and hence it will not satisfy. What about C? C is also not a subspace because यहाँ पे क्या condition है? The product should be 0. Can you give an example of V1, V2 such that V1, V2 belongs to C, but their some linear combination does not belong to C? Can anyone give example here?
Yes, ma'am.
Yes,
We can
Arpita.
take 0, 0, 1 and 0, 1, 0
0, 0, 1
and
and
0, 1, 0. 0, 1, 0.
0, 1, 0. Okay,
Yeah.
correct. So y into z. Y coordinate into z coordinate should be 0. तो यहाँ पे product 0 है. So yes, this belongs to W. यहाँ पे भी product 0 है. This also belongs to W, but when we add them, correct?
Yes, ma'am.
What we get is 0, 1, 1. Now y into z is not 0, so it's not a subspace. Only option left is A. You can verify that it satisfies this condition and hence is a subspace. Okay. I will leave this part. Let us go to the next. So read the question carefully. It's a long question. P, what is P representing here? P, if a system of linear equations Ax equal to B has a unique solution where A is an M cross N matrix and B is an M cross 1 matrix, then M equal to N. What do you think? Is P true?
No.
No, ma'am.
No, right? So it depends actually the rank of the matrix. Determinant पे depend करता है. Although M is equal to N, if the determinant is 0, it can happen na? Many square matrices have determinant 0. So सिर्फ square matrix से नहीं बोल सकते कि the solution has a unique solution. So P is false. Orally we can check. Now see the option number Q. For a subspace W of a non-zero vector space V, wherever U belongs to V minus W and V also belongs to V minus W, then the addition belongs to V minus W. So basically, in short, they are asking whether V minus W can be a subspace, at least for the addition part. For addition, they are asking. So the answer is again false. So let me give you a counter example. Can anyone think of a counter example? You can take V as R2. Yes. So I can take a straight line. R2 में subspace क्या आता है? Straight line ही आता है, right? X passing through 0, 0. All straight lines passing through 0, 0 are the only subspace in R2. So let me take one of them. Very basic line, straight line, x plus y equal to 0. अभी v minus w मतलब क्या? All those points where x plus y is not equal to 0. So now you have to find a u and v. Now can you give u and v such that u and v are in v minus w, but their addition does not belong to v minus w. Anyone? See, we are taking R2 as the vector space.
2 comma
Okay.
minus 1, 1 comma
2 comma
minus 1
hmm,
and 1 comma minus 2.
1 comma minus 2. Okay. दोनों का बट बेटा ये इट शुड बिलोंग टू v माइनस. हाँ करेक्ट. दोनों का एडिशन 0 नहीं है. x plus y is not 0, so u belongs to v minus w. And here also x plus y is not equal to 0. So this also belongs to. Correct. Very good. Now what happens to the addition? u plus v is 3 comma minus 3. जिसका एडिशन क्या है? 0 है. So it does not belongs to v minus w. In fact, it belongs to w. So what that means? Q statement is also false. So our answer is D. Both P and Q are false. Okay, so you can see that अभी हमने जो लीनियर सिस्टम का फर्स्ट पार्ट किया था वो भी यूज हो रहा है यहाँ पे इस क्वेश्चन में, और वेक्टर स्पेस का भी यूज हो रहा है। सो ऐसे कंबाइन दोनों चीजें यहाँ पे यूज हो रहे हैं। चलो, क्वेश्चन बहुत बड़ा लगता है बट एक्चुअली इट्स क्वाइट सिंपल। Everyone read the question properly. Take 1 minute and read the question. Is it visible to all?
Yes.
Okay. Please read the properly and try to understand कि उसमें क्या बोल रहे हैं। So here, I hope everyone has read the question. P11 of x, that is the vector space given here. Polynomials, all the polynomials of degree up to 11, having degree at most 11 together with the zero polynomial. So there are two subsets of P11 given. E में क्या है? S0 of x, S1 of x up to S11x, मतलब ऐसे 12 पॉलिनोमियल्स है E में। F में भी 12 पॉलिनोमियल्स है, R0 of x, R1 of x up to R11 of x. Okay, so 12 plus 12. Now what they are asking? Some condition is also given on the polynomials. The first condition is S0 of x, S up to S1 of x up to S11 of, sorry, S0 of 3, S1 of 3 up to S11 of 3 is 0. Now see, what is S0 of x? S0 of x is belonging to this particular vector space. Matlab, it is a polynomial of degree at most 11. So it will be of the type like this, A0 plus A1x plus A2x square up to A11 x raised to 11, right? Similarly, I will have S1x, S11, ये सारे। तो यहाँ पे कितने अननोन्स है देखो, A0, A1, A2 up to A11, 12 अननोन्स है यहाँ पे। So when I write S0 of 3 equal to 0, S0 of 3 equal to 0 will in fact give us an equation. क्या आएगा इक्वेशन? यहाँ पे everywhere in place of x you have to put 3. So A0 plus 3A1 plus 3 square A2, no need to write everything. 3 raised to 11, A11 equal to 0. So उसके बाद S1 of 3 is also 0. That is also a equation. So इतने कितने equations है? S0 of 3 is 0. S1 of 3 is 0. Up to S11 of 3 is 0. So this will be a system. Everyone agrees? How many unknowns will be there?
12.
12 in the first equation. Second equation में 12 वापस, sorry, 12 correct. A0, A1, A2 up to A11. सेकेंड इक्वेशन में भी अलग अलग हो सकते हैं, राइट? क्योंकि यहाँ पे कुछ दिया नहीं है कि पॉलिनोमियल सेम है, कोएफिशिएंट्स कैन बी डिफरेंट। सो S1 में कुछ B0, B1, B2, B11 होंगे, ऐसे LS11 में भी कुछ अलग अलग होंगे। सो दिस रिप्रेजेंट्स व्हाट? a homogeneous system. You can think of it as a 12 cross 12 homogeneous system, correct?
Yes, ma'am.
Right? So मीन्स ये जो हम लिखेंगे इतने सारे कोएफिशिएंट्स होंगे यहाँ पे 12 क्रॉस 12 कोएफिशिएंट्स। इफ वी नो द कोएफिशिएंट्स आल्सो, just concentrate on this part, that's a homogeneous system. So what do you think, कौन सा केस आएगा? होमोजेनियस का दो ही पॉसिबिलिटी है, ट्रिवियल सॉल्यूशन और इनफाइनेटली मेनी सॉल्यूशन।
Infinitely.
तो
Yes.
इसमें कौन सा आएगा? So you have to see whether m is less than n
नहीं
or m is greater than n. What do you think? M, number of equations कितनी है? Number of equations are 12. That is fixed, correct? And what about the number of unknowns? 12 into 12, 12 square, correct? So what we have? M less than n. M less than n means what? There is only trivial solution. Zero solution. Okay. Now what are the options if you see? They are asking about whether they are linearly dependent or independent. E. So what do you think? क्या आएगा यहाँ पे? ट्रिवियल
Independent.
सॉल्यूशन आया ना? यस, मतलब सारे कोएफिशिएंट 0 आएंगे, सो दैट गिव्स अस linearly dependent. Okay. And what about
Independent होगा ना मैम?
क्या हुआ?
एला ही होना चाहिए ना मैम?
नहीं नहीं, ट्रिवियल सॉल्यूशन मतलब क्या? जीरो सॉल्यूशन आएगा ना? When you take a linear, if I go in very detail, let me go in detail. Okay. So what they are asking you, whether set E is linearly dependent or independent. So how do you check linear dependence and independence? So you have to start with alpha naught S naught plus alpha 1 S1 plus, correct, up to alpha and Sn equal to 0. So when you solve this system, here you will agree that m is less than n. Hence what we are going to get is a trivial solution. And when we get a trivial solution, मतलब क्या हो जाएगा? See, that is the coefficients are all 0.
Zero,
So
yes
that
ma'am.
means the linear set E is linearly dependent. क्या है अपना definition? If you see, if the coefficients all 0, मतलब the linear combination में अगर सारे sorry, that's confusion. एक मिनट, just यहाँ पे कौन से unknowns 0 आएंगे? Trivial solution. What are the unknowns we are talking here? We are talking about this unknowns: A0, A1, A2, A11, and not about alpha naught. Because of the notations, you may have got confused. वहाँ पे हमने definition में A0, A1 यहाँ पे लिखा था. Okay,
Yes
let me
ma'am.
change this as alpha naught, alpha or alpha n. तो यहाँ के सिस्टम में unknowns का बात किसका बात हो रहा है? A0, A1, A2, A11. फिर S1 में है B0, B2, B1, B2 up to B11. ये सारे unknowns 0 आएंगे. ये unknowns 0 आ रहे means in fact the polynomials are 0. Do you get me? And
Yes,
hence
yes ma'am.
this becomes a linearly
Dependent.
dependent set.
Okay ma'am, correct.
Okay. Now
Yes.
whereas for F, यहाँ पे equal to 1 दिया है बेटा. So since it is given as equal to 1, it is a non-homogeneous system.
Non-homogeneous.
And non-homogeneous system may have non-trivial unique solution also. So it is, so what we can conclude is F need not be necessarily linearly dependent. E तो हमेशा ही linearly dependent आएगा, and hence the option is B. Any such E is necessarily linearly dependent, but any such F is not necessarily linearly dependent because the difference is in the homogeneous and non-homogeneous. In homogeneous, since m is less than n, we get trivial solution. So ये सारे polynomials 0 हो गए and hence linearly dependent. But in non-homogeneous, what happens? You got 12 cross 12 non-homogeneous system. Okay, in that also m is less than n. So we may have non-trivial solution. In that case, we get that not necessarily linearly independent. I hope this is clear to all.
Yes, ma'am.
Okay. So this confusion is clear, right? That's why I changed the notation here to
Yes, ma'am.
alpha
वहीं
naught.
पे कंफ्यूजन हो रहा था
हाँ.
थोड़ा.
Okay. Any other doubt in this particular question?
No, ma'am.
Okay. Now we have a similar question here. Again, I will leave it to you. इसमें भी polynomial दिया है P12 11 degree at most 12 along with 0 polynomial. Function f मतलब is a polynomial here. Conditions are given. F of minus x is equal to f of x and f of 224 equal to 0. Correct? So यहाँ पे dimension का है. So let me do it. It's a little bit different problem. So v, any polynomial f will be of the type a0 plus a1x plus a2x square up to a12 x raised to 12. Now here we have to find the dimension of v. Okay, p12 का dimension क्या होता है? p12 of x.
13.
13.
No, dimension will be
13.
13 n plus 1 because of the coefficient. और इसका basis क्या होता है? 1 x x square up to x raised to 12. So these are in total 13 and hence the dimension is 13. Now here v contains all the polynomial of this type. Okay. अभी यहाँ पे हमें चेक करना है डिग्री विल बी लेस देन और इक्वल टू 13 बिकॉज v इज अ सबस्पेस ऑफ p12. तो इसमें कंडीशंस क्या क्या दिए है? फर्स्ट दिया है, एक तो दिया है f of 2024 is 0. So what will this give immediately? It will give us an equation that is a0 plus 2024 times a1 plus 2024 square times a2 up to this raised to 12, a12 is 0. So what I can get is a0 is actually a linear combination of a1. I can write like this. You can take any variable. Simplicity, I'm taking 8 0. So I can write a0 as a combination of these two. So here out of this 13 variables, a0 will be removed. Okay. So 13 से हम 12 पे आ गए. और भी आगे क्या दिया है? f of x is equal to f of minus x for all x. Okay, you can take any x. So if I take say f of 1, f of 1 equal to f of minus 1. What will this give? f of 1 matlab a0 plus a1 plus a2 up to a12 equal to f of minus 1 means to get a0 minus a1 plus a2 minus a3 alternate up to a12. So here when we simplify, all the even will get cancelled. a0 is getting cancelled, a2, a4 up to a12 cancel हो जाएंगे. I can adjust this a1 minus a3 all together. Taking on the left hand side, we get 2a1 plus 2a3 so on up to you will get 2a11 equal to 0. Correct?
Yes, ma'am.
So what we can do here? 2 से तो divide हो जाएगा ये. So I get basically a1 plus a3 plus a5, a7, a9 up to a11 is equal to 0. So again I can write a1 as a linear combination of a3, a5, a7, a9 up to a11. तो एक और reduce हो गया 12 से 11 पे आ जाएगा. Like this, I can do this for every x दिया है ना, for all x.
Yes,
तो
ma'am.
unknowns तो fixed है अपने. Suppose I take f of 2 equal to -2. So it will again give us a system. So f of 1 equal to f of -1 will give us a1 plus a3 plus a5 up to a11 is 0. Similarly, I can take f of 2 equal to f of -2. That will give us what? इसमें थोड़ा अलग आएगा. यहाँ पे सब 2, 2 square, 2 cube. यहाँ पे भी 2, 2 square, 2 cube. Like this you will get. So whatever it is again a polynomial in terms of a1. पे 2 cube है ना, 2 cube a3 up to 2 raised to 11, a11 equal to 0. Like this, I can take, see how many unknowns are there, a1, a3, a5, a7, a9, a11. 6 unknowns are there, right? So if I take up till f6, or I can take even more than that also. So what will happen? In that case, our equations will become more than unknowns, and it's a homogeneous system. That means the only solution is trivial solution. That means a1, a3, a5 up to a11. ये 6 के 6 सारे 0 हो गए. So already हम 11 पे आए थे, right? a0 is dependent on this. So we got reduced from 13 to 12. Okay. उसमें से भी अभी 6 0 हो गए. So what are the left? Only left are 12 minus 6. How many will be left? 6. So उसमें से कौन सा आएगा? a2, a4, a6, a8, a10, a12. इतने ही वेरिएबल्स रह जाएंगे. So the basis will be x, a2 का coefficient, that is x square, x raised to 4, x raised to 6 up to x raised to 12 will be the basis of this particular set. बाकी सब either 0 हो रहा है, और सारे 0 हो रहे हैं, and a0 is dependent on all this. So I can remove that also. So what you will get, that the dimension is basis थोड़ा अलग आएगा, because we have to write a0 in terms of this remaining, but idea is same. How many are left? These are the 6 variables left, and all these are linearly independent, and hence dimension of V will come as 6. So for finding dimensions, this is what you have to do. Reduce the dependent variable. जो dependent variable है वो सबको निकालो, और 0 भी निकालना होता है. Linearly independent में 0 नहीं चलता. So linear basis चाहिए, dimension चाहिए, मतलब basis means linearly independent, and hence all the dependent variables we are removing. इसमें dependent variable क्या है? a0 is the dependent variable, उसको निकाल दिया. उसके बाद ये सारे zeros है, इसको भी निकाल दिया. So बचे हुए linearly independent variables इतने हैं, these coefficients, and hence we get dimension of V equal to 6. Is this clear to all? Like this we can solve the other problems also, dimension पे ही है. उसके बाद है linear transformation. Linear transformation में, let me move directly to the problem. ज़्यादा नहीं यूज होता linear transformation में. You need the definition. Okay, that is T of 0 vector is 0, where T is a map from V to W to vector spaces. First condition is 0 vector should be mapped to 0 vector, and second is T of alpha V1 plus beta V2 should be equal to alpha T of V1 plus beta T of V2. Other than that, what is used is kernel of a linear transformation. That is all x belonging to V such that T of x equal to 0. Means all that are mapped to 0. Then one can verify that kernel is always a subspace of V and hence uska dimension exists करता है, and dimension of kernel of T is called as nullity of T. Similarly, we have image of T or range of T. Image बोलते हैं, range बोलते हैं. That is range space. All the image T of x for all x belong to V. So clearly this is a subset of V and in fact this also comes as a subspace. Subspace है मतलब उसका भी dimension निकाल सकते हैं and the dimension of image of T is called as क्या बोलते हैं? Rank T.
Rank of T.
And we have the rank nullity theorem, very famous. Rank of T plus क्या है?
Nullity of T
T
equal to
equal to
dimension of V.
V. Correct. This is यही ज्यादा यूज होता है. उसके कुछ थेरम्स भी होते हैं. उसके बाद मैट्रिक्स ऑफ टी भी आता है related to a linear transformation. So you can take an example here. T of x, T of f of x is given as f of x plus derivative of f of x. Let me write in short f dash of x. And it's a polynomial of degree 7, at the most 7. And it is linear transformation दिया है. Check कुछ नहीं करना है. So you have to check whether which of the following is true. The T is not a surjective linear transformation. There exists k belonging to n such that T raised to k is 0 linear transformation. 1 and 2 are eigenvalues of T. And there exists R belonging to n such that T minus I raised to R is the 0 linear transformation, where I is the identity map. Since it's a polynomial, you know that polynomial का degree आप derivative बाद में 0 होगा, correct? F belongs to P7. 7 अगर 7 डिग्री का है तो उसका कौन सा डेरिवेटिव 0 होगा? 8th डेरिवेटिव, राइट? 8th
Yes,
डेरिवेटिव
ma'am.
ऑफ F
Yes,
इज ऑलवेज 0 और उसके आगे के भी सारे 0 होंगे. सो व्हाट यू कैन थिंक कि B और D में से कुछ आ सकता है क्योंकि ये पॉलिनोमियल है. T रेस्ट टू, सो वी कैन फाइंड दिस T रेस्ट टू K, T स्क्वायर ऑफ F क्या आएगा? T of F plus F dash. T of F plus F dash. What will be this? Yes. If T of F is F plus F dash, what will be T of F plus F dash? That is, it's linear transformation matlab T of F
T of F plus T of
plus
F
T
dash.
of F dash. So what that gives? T of F is again F plus F dash,
F plus F dash.
and this will be F dash plus F
F
double
double
dash.
dash.
So F plus 2F dash plus F double dash. अभी देखोगे तो यहाँ पे F है, F dash है, F double dash है. So you can say that inductively you can think कि T cube क्या आएगा? तो T cube में भी F तो हमेशा ही आने वाला है, right? तो F तो आ
Yes.
रहा है तो ये 0 नहीं हो रहा. That is clear कि B ऑप्शन में ये 0 नहीं हो रहा. So what we can do is let us try this T minus I raised to R. कि उसमें 0 होगा क्या? T minus I of F is what? T of F minus I of F. T of F is given as F plus F dash minus what is I of F? Identity of F, matlab F. So this F is getting cancelled. What we get? F dash.
Yes,
Now
ma'am.
see, F चला गया, सिर्फ डेरिवेटिव है. So T minus I square of F क्या आएगा? t minus I of t minus I, which is f dash. So it will be hence f double dash. So सिर्फ डेरिवेटिव बच रहा है. So we already know 8th डेरिवेटिव 0 है. That means when I go to t minus I raised to 8th power, when I take, it will be 8th derivative of f. And since it's a polynomial of degree 7, it has to be 0. And hence, we can conclude that D option is correct. No need to check the remaining because question number 22, it lies in the MCQ. MSQ रहेगा तो multiple select question रहेगा तो you have to check the other options also. But it is a multiple choice question. So D option we are getting, there exists R belonging to natural, such that T minus I raised to R is the zero linear transformation. R क्या आया यहाँ पे? 8 आया.
8. Yes, ma'am.
So this is 0 for any polynomial. So what we get here? Answer D option. Okay. Now see, in this particular example, we can use rank nullity theorem. There, they are given two statements. The first statement says, there exists a linear transformation from R3 to itself, R3 to R3, such that its range space and null space are the same. Range space मतलब range space का dimension आएगा rank t.
Rank, yes, ma'am.
So rank t is equal to nullity. That is what they are giving to us. Now if rank t is equal to nullity t, that means will it satisfy the rank nullity theorem?
नहीं.
No,
नहीं,
ma'am.
क्योंकि इनका addition 3 आना चाहिए and the dimension has to be a natural number. So if they are equal, they can be 1, 1. 1 plus 1 is not 3. And if they are 2, 2, 2 plus 2 will be 4. So first statement is not possible.
Yes, ma'am.
And what about the second statement? There exists a linear transformation T from R2 to R2 such that its range space and null space are the same. So is this possible? This is possible, right? Because since यहाँ पे dimension of V क्या आ रहा है? Dimension
2.
of V is 2.
Yes, ma'am.
I can have the possibility of 1 plus
1.
1 equal to 2. And hence we get option C. 2 is true कि possible है, there may exist, but 1 is surely false. So यहाँ पे rank nullity theorem use करना है. Now this is a very simple and direct question, but it is a multiple select question number 39. Hence MSQ में है ये. तो कौन सा linear transformation है? The very first thing is 0 should be mapped to 0. Okay. So इसमें से ये चला जाएगा. C option चला गया, right? T of 0 is not equal to 0 in this particular option. What else? बाकी इसमें आ रहा है, सब में T of 0 0 आएगा. Other properties what? T of x plus y equal to T of x plus T of y आना चाहिए. Is this possible for sine? No. Sine of x plus y is not equal to sin x
Sin
plus
x
sin
plus
y. तो
sin
ये
y.
भी not possible है. Trace में आता है? Yes. Polynomial में भी आता है? Yes. And the last property is T of alpha x should be alpha T of x.
Yes, ma'am.
This is true for trace as well as for the polynomials. So the correct option are both B and D. So multiple select है, दो options correct. Very basic thing, just the definition you have to verify. This is also a straightforward question. Rank पूछा है, rank of P. So here P2 दिया है, मतलब polynomial P of x will be of the form A0 plus A1x plus A2x, second degree. And what is the linear transformation given? T of P of x is getting mapped to P of x square. You have to find rank T, मतलब dimension of image T. Image T is what? All the images. मतलब all T of P of X we are collecting, where P of X belongs to our polynomial P2R. So that is what? P of X square. Okay, for all P of X belonging to P2R. So P of X square क्या आएगा? A0 plus A1 X square plus A2 X raised to 4. Where what are this A0, A1, A2? They are all constants. तीनों में कोई भी कॉम्बिनेशन नहीं दिया प्रीवियस एग्जांपल्स के, जैसे कि P of 1 0 अगर कुछ देते तो हमें वी कैन राइट A0 इन टर्म्स ऑफ A1 A2, बट ऐसा कुछ एक्स्ट्रा कंडीशन नहीं दिया है, मतलब तीनों भी इंडिपेंडेंट है. सो दिस इज एक्चुअली लीनियर स्पैन ऑफ द पॉलिनोमियल्स 1 X square and X raised to 4. Okay, P2 to P4 है, I think it's not visible. Of course this will come from P2 to P4. और हम रेंज देख रहे हैं, यहाँ पे होता है रेंज. डायमेंशन एट द मोस्ट 4 होता है, बट यहाँ पे 3 आया. 1 X square X4, this is the basis. So here what is the rank? Dimension of image T is 3, because you are getting 3 elements in the basis.